All right, so here we have a pendulum problem. Okay, this is a little bit of a complicated one, as you've seen. We're taking a pendulum in an elevator, and initially the acceleration of the elevator is just going to be standing still. And then we've got the elevator accelerating down at 3 meters per second squared. And the idea then is we're trying to find the change in frequency. Okay, so we want that, delta F. Okay, so we're not looking for frequency division, but to do that we need to find the frequency initial and the frequency final. So we're looking for f of 0 and f of 3. Okay, we're going to denote them there. All right, so there's no equation for the frequency, but there is an equation for the period. And so for this one we're going to have equals 1 over t, and we know that t is equal to 2 pi square root L over G. Okay, that comes out to be 2 seconds, which means our frequency is 1/2. Piece of cake. Now, when it's accelerating downwards, we've got kind of a different situation. All right, we still have it's 1 over t, but the problem is that we have to deal with gravity here. This isn't just going to be g. It matters. It doesn't just stay negative 9.8 no matter what. It's not going to be that. So what we have to do is we have to consider the fact that this gravity is really a difference between the surroundings and the pendulum itself. Okay? What's the kind of acceleration of both? Okay? So it's really relative. So we know that the elevator here was g equals 9.8, and the elevator equals 3 or equals 0. Okay, so we plugged in g, but here it's g equals 9.8, and the elevator is equal to 3. So what we really want is g relative. Okay, so that's actually going to be g relative equals 6.8. Okay, we're going to plug in that being 1, again to 1 meter, and we end up getting a period of 2.4 seconds. Take it over here. 1 over 2.4 equals 0.42 hertz. And because it equals 0.2142 hertz, again, let's go look back at what we're looking at. We're looking for the change in F. Okay, and that's going to be and that's going to give us a decrease of 0.08 hertz. All right, and that's a relatively simple, but with moving gravitational or a moving elevator pendulum problem.